Hi, I'm Mrs. McTaggart, and in this video we're going to look at what's called distance time graphs. So this is a visual way of plotting distance, the distance of a journey against the time taken in a journey, and from that we're going to be calculating speed. So before you start watching this video, make sure that you are familiar with basic line graphs and you have already seen how to do speed, distance and time calculations. So this is the first of my examples. This journey shows May is going on a return journey to collect her daughter from a school trip. So the first part of the journey, I'm just going to talk to you about what's happening. So part A is she's travelling outwards. So she's travelling along. And then at part B, you'll notice the time goes on, but the distance doesn't. So if your time ticks away, but your distance isn't moving, that means you're stationary. So she can be stuck in traffic, she could have stopped at shops, something like that. And then she continues on her journey to wherever she's to get her daughter from. And then she travels all the way back in one go. So that's what that represents, all right? So things they can ask you is maybe at what time did she stop for a break? And you would look at it, right, she stops here and say, right, she stops at 10 o'clock. They might ask you, well, how long did she stop for? And you'd say, right, okay, from there to there is 2 boxes. And then if you look at the bottom, between each hour is 4 boxes. So each box is worth 15 minutes. So you would say that she stopped for 30 minutes. It'll also ask you other things like in what part of the journey was she driving the fastest and how can you tell just from looking. Now, a wee tip is a bit that's going the fastest is the steepest line. Now, the steepest line could be going up the way or it could be going down the way. So whichever is the steepest is the fastest bit of the journey. And from looking at this, you'll see that this bit is the steepest part. So part D, the return journey, was the fastest bit for her. So in what part of her journey was the fastest? So the answer would be the return journey, as it is steeper. And that's all you would have to say if that was a question. But looking closely at it, she's doing the same distance as her journey out, but it's only taken her 1 hour compared to the 2 hours on the journey out the way. So the main thing we actually want to do is for these questions that ask us to find the speed for each part of the journey. So I'm going to do part A first of all. Now, speed equals distance over time. If you've forgotten how to get that, remember you can do your little triangle and it is D at the top. Oh, I can't fit that in. Then S, then T. So speed would be left with D over T. So for part A, her distance was from there to there was 60. And her time was 1 hour. So her speed for part A was just 60 kilometres per hour. Her speed for part B, she is stationary. So her speed is 0 kilometres per hour because she's not moving for part B. For part C, her distance is from 60 up to 100 is 40. And her time is half an hour. So it's 40 divided by 0.5, which gives you 80 kilometres per hour. And on the last bit, part D, her speed back the way, her distance is a full journey, which is 100, and her time was exactly 1 hour, so her time was 100 kilometres per hour. And then we can just see that what we said in the first bit was true. The fastest bit of our journey was indeed part D. Okay? My example is one of a pilot. So the pilot is flying his plane from the airport to a place called Stoneville to pick up some passengers, and then he's coming out. So this is the outward journey and this is the return journey, and this is a bit where he is stopped or stationary. Alright, so they're going to ask you some questions about this one. So for how long was he on the ground at Stoneville? So how long was he stopped for? So from the top, he was stopped for 3 boxes. If we check down the bottom, between 1 and 2 is 4 boxes. So each box is worth 15 minutes again. So he was stopped for 3 times 15, which is 45 minutes. Okay, so he was stopped for 45 minutes. What was his speed for the outward flight? So the outward flight, if you read down, took 1 hour. And the distance, although it's not written up there, continuing the sequence, 200, 250 would be 300. So his speed was distance over time. His distance was 300. His time was 1 hour. So he flew at 300 miles per hour on his plane. Okay? The weather was bad on the way back, so we have to calculate his return journey flight. So his return journey flight lasted from here to here. Now that is a time of, well, 4 boxes was an hour plus 3, so his time is 1 hour 45. His distance was 300. So speed equals distance over time. His distance was 300. And to write 1 hour 45, remember that's not 1.45, that would be 1.75, because 45 minutes is 3/4. And then if you do that in your calculator, you get, it's not a nice number, but we will round it. It gives you 171.428, so we'll say 171.4 miles per hour. And you'll notice that's a lot slower than he did on the way out. On the way out of the journey, he did 300 miles per hour. On the way back, he's 171. So we can see that the bad weather has affected his speed. Right, my last example, the last style you can have are 2 people travelling between the same towns, but one's going from A town to B town, and one's going from B town to C town. So Bob and Mick are delivery drivers who travel daily between these 2 towns. Okay, so Bob is in blue and Mick is in pink, is in red, sorry. So Bob is setting off from A town and Mick is setting off from B town. So question is, who sets off first? So let's look at our times. Bob doesn't set off until 1:15, but Mick sets off straight away at 1 o'clock. So Mick sets off first. So that should actually say who arrives first. So who arrives first? We can clearly see that Bob gets there first. His journey's definitely a lot shorter, so Bob gets there first. And then it says, who's driving fastest? Well, clearly it's Bob. He left later and got there before the other guy, but then just looking at the steepness, again, Bob was going fastest. So Bob, because it's got a steeper line. Okay, and remember that steeper line means the fastest part of the journey. Then the last thing's like, how far is it between the 2 towns? So that's looking at your distance column. So following the pattern, every 4 boxes is worth 50. So that makes Beaton worth 150 kilometres. So the towns are 150 kilometres apart. Then it looks like the two drivers are meeting each other. They're not going to be colliding because that would be dangerous. But if one's going one way and one's going the other, there will be a certain point they'll pass each other on opposite sides of the road. So it says, how far from Beaton are they when they pass each other? So this is when they pass each other. And the distance from Beaton is from here to here. Now, each box must be worth 50 divided by 4 is 12.5. So the distance away is 50 plus 12.5 is 62.5 kilometres away. Okay, so they're 62.5 kilometres away from Beaton. If they'd asked it the other way, you would have said they were 87.5 kilometres away from A town. And then it says, and when do they pass? So time-wise, if you draw that down, time-wise would have been at 2:15 p.m. Okay, so remember they're not colliding, they are passing each other. All right. And then the last thing they'll ask you to find each driver's speed. So I'll set off with, let's do Mick first. So Mick, speed equals distance divided by time. His distance was 150 and his time was exactly 4 hours. And 150 divided by 4 is 37.5. So he was driving at 37.5 kilometres per hour.